I want to conclude with saying a few words about deferred annuities. So what we're going to do now is we consider an annuity that is payable to policyholder age X. We've got annual payments of €1 starting at age X plus U, right? So there is no payment guaranteed. There is no payment before age X plus U in this product. So what can we do then? The notation is U bar. So again, for the U years of deferment, A double dot X. And what we can see is that if we combine the U year term annuity due with this U year deferred annuity due, then again, we've got a whole life annuity due issued to an X-year-old, right? So that is something we could also write down using our summation formulas. I'll do that in a minute. But intuitively, we can say if you've got a whole life annuity due, you can say I've got first a term product with a duration of U years. And then after that, I've got a deferred whole life annuity kicking in, right? And then, of course, you can massage these expressions and retrieve an expression for the EPV of the deferred life annuity. Now, something I want you to be aware of and want you to be able to play with is, of course, our summation formulas for this type of annuities. So perhaps let's do this together to, I want to think about the whole life annuity issued to an X-year-old deferred over U years. Okay, so what I'm going to say is the first payment of €1 will be paid at time U if my policyholder is alive at that time, right? So if I would make a picture, I've got X, I've got time, I've got the period of deferment, which is U years. So the first payment is here, if I'm alive at that time. Then the next payment is over here, etc., etc. So I'm going to work with a discounting factor VU, VU plus 1, etc. And I'm going to work with a survival probability like this. Okay. So putting that together in my summation formula, I'll get the sum over K. K going from U to plus infinity of V to the power K if the interest rate is constant times KPX. Okay, so if I write that in full, I would get V to the power U, UPX plus V to the power U plus 1, U plus 1 PX, etc., etc. And what you know from the multiplication rule is that all these terms have got the following in common. I can put V to the power U times UPX in front, and I'm left with PX plus U, right? Plus V squared times 2PX plus U, and so on and so forth. Okay, so what I'm using here is again my multiplication rule for survival probabilities, so that, for instance, U plus 1 PX, it's UPX times 1 PX plus U. That's the kind of reasoning that I'm using here. So putting that all together, what do I recognize? I recognize in here the valuation formula, the EPV, of a whole life annuity due, but now issued to an X plus U year old. So if I put that together, I've got A double dot X plus U. So that is something we also recognize from what we did with deferred life insurance products. You've got the corresponding product issued to an X plus U year old, but if you need to value this deferred product at time 0, you still need to multiply with the actuarial discount factor, and you need to go from time U to time 0 with a V to the power U, but also with this survival probability, the UPX. And here you see where these summation formulas are coming from, right? Maybe as a last thing, let us then think about the following relation. So I've got a term insurance, I've got a deferred, sorry, I've got a term life annuity, I've got a deferred life annuity, and I want to convince myself that that is the same as looking at the whole life annuity due. Yeah, so if I look at the term product, I'm going to go for K running from 0 to U minus 1. I'm going to work with V to the power K, KPX. And if I work with the deferred products, I'm going to go from U to plus infinity, V to the power K, KPX. And of course, if I put that all together, that's exactly the same as having a sum running from 0 to plus infinity, V to the power K, KPX. Now, that's just a matter of splitting the sum in what is happening before time U and what is happening from time U on. So rewriting it slightly, we would have the following identity. So we've got then, like Sally said, it's the UEX multiplied with the whole life annuity issued to an X plus U year old, and that is equal to the whole life annuity issued to an X year old. Yeah? So that is sometimes referred to as the splitting identity for life annuity products, but you see it coming up over here. So that's what I meant with this part on the deferred annuities. And then a picture to conclude. So here you see the period of deferment going from 0 up to U minus 1. And then my first payment will kick in at time U, next payment at U plus 1, etc. I've got my discount factors, I've got my survival probabilities. So I need to combine these to put together the valuation form.